Okay, so let's just look at the vectors and how to find a component of a vector. So let's say I'm gonna choose a vector, and the vector will be such as this. So let's say I have vector A, and the question is, how do we find component or resolve a vector into a component? So there are two ways how we can ask this. So you could be asked, find components of a vector, or we could say resolve a vector into its components. Okay, so how do we do this? So whenever we have a vector and we want to resolve this vector, so essentially we obviously would know the angle here. So to resolve a vector into its components, what we do is we come to the end of that vector and we draw a perpendicular line towards the x-axis and then perpendicular line towards the y-axis. Right, so these lines are perpendicular, 90 degrees. And where they intersect, we get another two line segments. And these line segments are our components. So we will call this AX, and you can see that I'm going to use the arrow because those components are vectors themselves. And now if we would apply the graphical method, we know that AX vector, if we add it up with a y vector, they will give us the vector A. Now, how do we find the magnitude of x component of this vector? Well, it's going to be the magnitude of vector A times cosine of the angle theta, and the magnitude of vector y will equal to magnitude of the times sine of theta. So what I'm doing here, I'm just simply using trigonometry. Right? Now, I was given this angle. If I was given this angle, maybe these sine and cosines could change. Or you could always calculate this angle and use these formulas. So please just be aware that how you calculate it is really application of trigonometry. You don't have to worry about it. Okay, so sometimes you will see that this is this could be also looking. Okay, so I'm just going to now briefly show you how these components could be represented visually in different textbooks in different situations. So one way, if you look at it here as a vector, you can see that if I have my vector v, this would be technically the x component of that vector, and this would be y component of that vector. This is a nice way to represent it if you look at this method, just to see it in terms of the head to tail, all the graphical method. So it's the x component plus the y component equals the resultant, right? So that's one way to look at it. The second way is sometimes that the vector does not need to be at the center of the coordinate system. I personally usually like that, but it's really up to you as you're going to build comfort with this topic. So then this would be also my, in this case I have vector f, x component of that vector, and fy component of the vector. Again, both of these are valid. It's not the case that one of them will get you in trouble. I just want you to be familiar with all of them. Choose the one that works for you, or maybe sometimes you will choose the one depending on the problem and situation. So this is just a small video on how to find components of a vector and how to actually calculate them. Maybe I'll mention one more thing, and that would be just think about the coordinate system and the signs. And it's important to understand that any vector that is here, the components will be both positive. Oh, sorry, I need to actually erase that. Right, so any vector here will have positive components. This one here will have negative positive components. This one here is going to have negative component. And here is going to be positive and negative. Right, so this is the x and y. Right, so for any vector, we could write that as a coordinate type of bracket. Right, so just to be aware that sometimes these signs will be different depending on where the vector is placed.